the spoofed MAC attack. This attack basically creates a fake AP with the same MAC address as one of the infrastructure APs. In order to generate this attack, we'll be using a lot of the tools that I mentioned earlier, AirCrack NG, Airmon NG, and Airbase NG. So all of these steps that we need to do, we have encapsulated in a shell script, and we'll be providing the script later. I'll show you how to run the attack. So the script is called spoofed MAC. Either same channel, you can do it for same channel or for different channel as well. Now let me show you what this script has. So it basically does a clean, which basically removes any existing Airbase NG or DHCP program which is running. The devices script basically asks you which wireless card you want to run the test from. If you have multiple cards, it will show you a listing of those cards. The access points script, or it's basically a file which contains a listing of the infrastructure access points and their MAC addresses and their channels. You will need to update this file with the information from in the area where you want to do the attack. So right now I have pre-populated it with two of the APs which are present in my setup. Then it basically just shows you a listing of what parameters it will be using. Then it changes the MAC address to this of the wireless card to the one that you provided, and then it starts the fake AP using Airbase NG. It also starts some forwarding, so that forwarding setup, so that using DHCP, so that users can connect to that fake AP. So in order to run this test, you just run this script. It will start by killing any existing Airbase NG processes, DHCP processes. Then it will asks you which Wi-Fi adapter to use. I have only one, I'll use that one. Then it asks you which MAC address to spoof. I'll just spoof the second one. Then it uses Airmon NG to remove the monitor interface and again start the monitor interface on WLAN 0, and then it sets the spoof MAC address. So this is the current MAC address of the wireless card, and this is the fake MAC address. Then it starts the fake AP. This attack will be detected by whips, and it will be shown in NCS along with the location of this attack. Auth flood attack. For this attack, I'll be using a different client. The client laptop, as you can see, is already connected to my infrastructure SSID card demo, and I will start a ping on the local network so that you can see what are the effects of the attack. So I've started the ping on the client laptop, and I also need the MAC address of the AP to which the client is currently connected to. So on the attacker laptop, I'll be using the tool AeroDumpNG, and I'll try to first find which client is connected to a particular infrastructure AP. So I look at channel 6, DSS ID is 24, D6. And for this attack, you need to make sure that mon0 is already set up using airmon-ng. So I've started aerodump ng, and it shows me that for this AP, a particular client is connected to it, and this is the client MAC address. So I'll copy this client MAC address and stop aerodump ng, and now I'll use air replay ng in order to generate this deauth flood attack. To start it, I use -0, which indicates to it to start the deauth attack, and I'll provide it with the infrastructure AP MAC address, and the client MAC address, and run it from mon0. So as you can see on the client, ping is unreachable, and the client has been disassociated from the infrastructure SSID card demo. So this is how you generate the deauth flood attack. This attack will be detected by VIPs. Now that I've shown you how to generate VIPs attacks, let's look at how Cisco VIPs detects and displays these attacks using NCS. If you go to the NCS home page and click on the Security tab, you can see which attacks are currently active, which are seen in the last hour or in the last day. So we generated the deauth flood attack, and as you can see, it is showing it as active. If you click on it, you can go to the individual attack and see more details about it. You can even see the channel, the location, as well as the AP which detected the attack. For more information about the location of the attack, you can go to the sitemaps page under monitor and go to the particular floor on which the attacks are generated and are detected. If you click the show VIPs attackers button, you can see the location of each of the attacks that are being detected on the floor map. You can also see more details about each of the attacks by clicking on each of the icons. Different icons display whether the particular attack is a victim or attacker or an unknown device. You can also filter particular types of attacks using the filter provided in the box. So if I select the deauth attack, you can see that it has filtered all other attacks out, and it only shows the deauth flood attack and its location. So in this way, Cisco VIPs and NCS will show you all the attacks that are being detected and will allow you to pinpoint the location of those attacks. Next, I'll be showing you a feature which we are introducing in 7.5 called AutoMac Learning. This feature will protect valid clients on your network from connecting to rogue access points. Whenever a client is connecting to rogue access points, the controller will check with the MSC whether the client is a valid client, and if it is, it will prevent or contain the client from connecting to the rogue access points. Now let's look at a demo of this feature. Here I have a client laptop and an infrastructure SSID card demo. I'll connect the client to the card demo SSID, and that will make the client a valid client. This valid client will show up on the controller. Now that the client has associated with the infrastructure SSID, let's try and connect it to a rogue access point. Here in my current setup, card demo is the infrastructure SSID and alpha is a rogue SSID and with the rogue access point. So let me try and connect to alpha. After I connect to this access point, WIPS will detect that a particular client is connecting to a rogue access point, and it will try to determine whether the client was already seen as a valid client. If it was seen as a valid client before, it will try to prevent the client from connecting to the rogue access point. Here on the controller, we can see that the particular client is now shown as a rogue client and it has a status of containment pending. After some time, the controller will try to contain the client and it will move it to the contained state where the client will be disassociated from the rogue access point. Now let's look at the client again. As you can see, the client has now been disconnected from the rogue access point due to the containment action taken by the controller. This is how AutoMac Learning feature protects valid clients from connecting against rogue access points.